Welcome back to the Emerging Technology Showcase. Yes, woo indeed. Our next speaker holds several patents, has authored more than 40 technical publications, and has won numerous awards, including the Charles F. Jenkins Lifetime Achievement Emmy Award and the U.S. Broadcasting and Cable Technology Leadership Award. Presenting advanced video coding technology with ultra-low latency for connected acquisition, remote and cloud-based live production. Please welcome the Chief Technology Officer of Sony Electronics Imaging Products and Solutions Division, Hugo Gaggioni.
Well, that sounds very impressive. Okay, good afternoon, everyone. I'm going to try to be as quickly as possible to fit the amount of time that I have. This is the agenda of the topics that I will be covering this afternoon. I will emphasize some topics more than others, specifically the area of ultra-low latency, high-efficiency video coding, which is a new implementation of a compression algorithm to facilitate ecosystem transfers between ground and cloud and so on. This probably you have seen this presentation, this image many times before, but Sony has been investing very heavily in the implementation of a hybrid environment between on-prem production as well as in on-cloud production. And each one has their own set of constraints and challenges. Specifically in the area of on-prem and the communication between the on-prem devices and the cloud devices. And we have a company that we acquired a number of years ago, Nevio. We have been doing a lot of research and development to improve that connectivity between ground and cloud communication. Some of the challenges is, for example, resource and network orchestration, how we can distribute the resources that we have, how can we balance the payload that we have in the IT switches across multiple geographical locations. This is the area of network and resource orchestration. In the other end, we have people are talking about cloud operation all the time, but in reality, many customers are still preferring to have to reuse the resources they have on-prem. Therefore, this notion of a hybrid operation between on-prem and cloud operation is very, very important to be able to reuse the equipment that you already invested. But the topic of today that I want to emphasize is the one in the middle, media transport. We have to create new algorithms and new way of transmitting data in order to facilitate that communication. How to interconnect cloud and on-prem environments. This is the ecosystem, the vision that Sony has to manage and control and distribute resources across multiple areas of live production. And the key here is the word live production, where latency is extremely important for to create a live operation. Then whether it's from the venue to the cloud, from the venue to the data center, from the venue to the truck, something called A2P, AI automated production, or cloud switchers, M2L. These are all a very important part of the ecosystem. But as you can see, the key challenge that we have is the bandwidth for interconnection of these locations. The 4K is about 10 gigabit per second of payload. 1080p is about 3 gigabit per second of payload, 2.5 gigabit of payload. Then to have that to access that kind of bandwidth on the fly, on a spur of the moment, is almost impossible. Even if you talk to the telco carriers, that bandwidth is very expensive to set up between locations. Then Sony has been researching what is an ubiquitous bandwidth that we can have very easily access to. And we decided that 1 gigabit is now very, very easy to obtain from any of the telco suppliers. Then our goal is to put over 10 cameras of 4K in 1 gigabit per second, close to 40 HD cameras in the payload of 1 gigabit per second. And to do that, you need some very unique compression algorithms, or at least implementation of existing algorithms. You may know that very popular for outside broadcasting productions is the use of JPEG access from the trucks to the data centers or to the broadcast center. The latency is very important. This is a one frame latency, and this is why it's popular to use that in live production. Sony decided to investigate HEVC, high efficiency video coding. Also, the official name is H.265. And our goal is to be able to transmit, as I said, these multiple cameras of streams from location to broadcast centers to trucks to the cloud. And we are looking at data rates between 60 megabits, 100 megabits around for 4K. Data rates between 15 to 35 megabits per second for 1080 progressive. And if you do the math, it's very challenging to that type of compression ratios. Okay, let me give you a little bit more of information. There are three things that are always in conflict with each other in compression. You have picture quality, you have data rate, and you have latency. And usually you couldn't have the three of them. You only could have two. You can have picture quality and latency, a very short latency, but the data rates were through the roof, or vice versa. You can have a low data rate, a very beautiful picture quality, but the latency was painful. All right, let's see how we can solve that problem. And here I'm showing the four areas where we have to face latencies, delays in coding. We have the encoding area, we have the decoding area, and of course we have the transmission path. In very superficial terms, we have intra-frame compression, or I-frame compression. Therefore, the compression is to decorrelate information on a frame-by-frame basis without having to interact with the other frames. A long GOP, or long group of pictures, or inter-frame compression. Now we use the temporal correlation between the frames to reduce the data rate. But as you can see in the drawing, in long GOP, you still have to use an I-frame as an anchor frame to do your predictive coding and your bidirectional coding, and that introduces delay. And long GOP is, you can have 500 milliseconds, 100 milliseconds, multiple frames of delay. In Japan, and also used in North America and Europe, Sony has developed and optimized use of H.264, the predecessor of HEVC. And we call it, the commercial name is XAVC. XAVC is very popular for live production. It's 600 megabits per second, and it's intra-frame. Therefore, 600 megabit is less than 10 gigabit per second. It's more manageable, but it's heavy payload for files when you are recording. Then it began in Japan. We created a long GOP version of that, a long group of picture. It's 200 megabits. It's a factor of 3 to 1 lower. And in Europe and Japan and some broadcasters in the US, we exchange those files at 200 megabits per second. But still, for live production, the latency is still there. You're looking at 6, 7, 8 frames of latency, which is very painful for live sports. Then how can we drop that latency? Well, the usual way of encoding is you capture the frame and you encode the frame, and then you start distributing the bits. But another way of doing this is to do slices. We just take a frame and just cut it into pieces. You have to use multi-core, multiple versions of the encoder, and as soon as you finish your slice, you start sending the bits. You save quite a bit of delay. Therefore, what we have done is to try to eliminate the presence of the I-frame that we use as an anchor. And there's more details, but I'm not going to tell you everything. But we have to somehow put that intra-frame information in the slices so that every frame now is very tiny, and this can be transmitted very quickly. Then Doing this, using H.264, I can have less than 2 frames of latency and 200 megabits. But H.264 is old. Now we have H.265. Then using HEVC, I can have data rates between 60 and 100 megabits per second with less than 2 frames of latency, 30 milliseconds of encode and decode. And I tell you why this is important. Therefore, now we have multiple cores of encoding, and this is the actual structure of a H.265 encoder. And we have multiple repetitions of this in ASIC. This is a special ASIC that, because otherwise it's almost impossible to execute the encoding. The decoding can be done in software, but the encoder, we have devised an ASIC device. And we have done a lot of tests, POCs during the last 4 years to compare uncompressed 4K against JPEG access and compare HEVC ultra low latency. And as you can see, we can equate, remember, JPEG access is intra-frame. To do a nice coding of that quality, you need around 2 gigabits per second. If you drop it to 1.2 gig, it's a little bit soft. Therefore, you're looking at compression ratios of 6 to 10 to 1 in JPEG access. With H.265 or HEVC, I can now go 120 to 1, 100 to 1 compression, and the quality is identical as if I had intra-frame compression. Anyway, here you see some examples of how we eliminate the iframes in long up. The data rate of the compressed ultra-low latency are very minimal, and we can send them very quickly. This is for 4K at the data rate of 60 megabits. We also have the same performance with HD progressive at data rate of 25 megabits, 35 megabits per second. This is 25. Okay, we've done a lot of comparisons with competing products in the market, and this is, as I said, this is an ASIC that is optimized in encoding, not only for latency, but also for picture quality. We do a very careful assignment of macro blocks and data assignment in order to reproduce skin tones and details very precise, always maintaining under 2 frames of latency. Okay, this chip was announced about 2 years ago, and this device can handle 4 1080p's or 1 4K. And we are now deploying this device across many products that Sony makes. One of them is the ME80. This is a media edge processing engine or a LAN to WAN conversion engine. It has 2 chips. I'll give you more details in a minute. Also, we have a camera adapter that we use to communicate cameras over 5G to the broadcast center. And we have another device called a Virtuoso. Virtuoso is a product that comes from Nebion. We have it right here in the Sony exhibit. And we have now deployed a processing card supporting this chip. I'll say more in a minute. Okay, this is the media edge processor, the ME80. Essentially, as I said, it has 2 chips. It's capable of handling 8 channels of 1080p or 2 channels of 4K or 1 4K and 4 HDs. And it has a number of interfaces to communicate between LAN and WAN. Okay. Also accepts 2110 streams and so on. There you see some of the configurations. You can be a transmitter as well as a receiver. You can be sending 4 channels to the broadcast center. You can be receiving 4 channels from the broadcast center and so on. This product is now becoming very popular for live production, especially for sports application. If you have more than, let's say, you have 32 cameras in the truck, you can stack this unit and you just gen log them using PTP. Then now you have 2110 streams of compressed HEVC encoded material going completely synchronous to the receiving end. All right. Also, we announced at the Amsterdam, IBC, we announced the use of this unit to do cinematography. Now, a lot of people are doing remote locations. You can send 24 frames per second 4K material, compressed and at different data rates, and then this can be monitored, or the producer or the director of the movie can be doing use of these pictures remotely. All right, another area that we're using this technology is in 5G and cloud live communication. We have developed an adapter. This adapter connects to any camera, anything that has a BNC connector. It can accept a 1 4K or 1 HD. Can be HD interlaced, progressive. And this unit compresses using the HEVC ultra-low latency, and then communicates to a 5G or 4G infrastructure. Okay? Then there you see examples, whether it's a handy camera or a shoulder mount camcorder. As I said, the unit accepts the video streams over BNC, but the output of the unit is either wired or connection to a 5G gateway over USB connector. Then, as you can see here, the actual transmission to the 5G is through a gateway. This is a portable data transmitter that takes the streams from the compressor and sends them over 5G. Okay? The unit, this was originally introduced for the alpha cameras of still photography that Sony makes, but now we are using it in professional applications in sports. This is a portable data transmitter that can connect to all of the bands assigned for 4G or 5G communication, and it can be used for still photography, it can be used for live production, and we've been doing a lot of testing around the world. The most recent one was the coverage of the European football competition, and using handy cameras. This is the FX6 camera, and to our surprise, the broadcaster, the RTL, was also able to send control signals over 5G to control the cameras remotely. Therefore, the cameragraphers were in the field where the game is, but it's the broadcast station that is controlling the cameras, not the camera operator. This was bidirectional communication between the camera and the broadcast center. At IBC, as I said, is the equivalent of the NAB show, but in Europe, we had a demonstration of this bidirectional communication. What's happening is that sometimes you have your 5G, maybe a public network, maybe a private network, and you are competing for bandwidth. And let's say you have 2 cameras, and somebody is stealing bandwidth from that channel of communication. Then we have ways of orchestrate control of that bandwidth so that the camera that is on air has priority. And you are not dropping frames, you are not dropping anything. The second camera that doesn't have the extra protection may be losing frames depending on how many people are using the 5G channel. Therefore, this is what we call 5G bandwidth orchestration. Another very important challenge that we have is when you have a venue, a sporting event, the wire cameras are in the stadium, and the operators, the cameragraphers are in the field, but that signal that to get to the broadcast center or to the truck, it has to be under 100 milliseconds in order to be able to intercut the signal from the camera with the signal from the studio cameras. Therefore, 100 milliseconds is a magic number that now with this technology of ultra-low latency, it is possible. We have 30 milliseconds encode-decode, 70 milliseconds of transmission. Okay? This is another area where we are deploying this chip. This is for contribution. This is the Virtuoso product that Sony makes, and Nebion, and is the Swiss Army knife of processing. and it has JPEG 2000, JPEG XS, TICO, many signal processing modules that operate in the machine. We announced in September that now we have a card that has this device, this ASIC, the HEVC ultra low latency, capable of handling 4 1080p's or 1 4K. Therefore, one single Nebion Virtuoso product can have up to 28 channels of 1080p using all of the blades of compression. Okay, we plan to introduce not only on LAN and WAN, but in December we're going to announce the use of SRT. Therefore, to port HEVC ultra low latency over transport stream and SRT. Well, the final goal is to be doing this in the cloud. And we have a number of cloud services, the M2L family, multi-point to multi-point live. And now we are completing the software decoding of HEVC ULL in order to send directly from the cameras to the cloud switcher. Right now we are doing it with H.264 and other compression algorithms. But H.265 or the HEVC still, we need a little bit more development. Okay? But this is coming to be able to have cloud-based switching of HEVC. Well, and with that, thank you very much.